Hey guys, welcome back. Today I'm going to share to you some questions on permutation and combinations. Two of my students asked me if I can make a short video on permutations and combinations. So here it is. Let's say if I have a four-letter word, M-A-T-H. How many different ways I can arrange this word, even if the word does not make sense, but without repeating the letter. So on the first part, I can have any of these four letters. I can have either M or A or T or H. So four spots for any of the four letters possible here. On the second spot, I will have, once this letter is fixed, I can't use it. So I will be left with just three letters and then two, and then according to fundamental principle of counting, I can multiply these to get the total possible outcomes, which is going to be 24. This 4 times 3 times 2 times 1 is also called 4 factorial, which is 4 times 3 times 2 times 1, or 24. Similarly, 5 factorial is 5 times 4 times 3 times 2 times 1, or 120. 0 factorial by definition is 1. Now this fact can also be represented in a permutation or permutation formula like this. And if you have n objects and you want to, and this is a symbol for permutation, but we read it like this: n pick r. You have n objects, you want to pick r of them, then you can write down like this: n factorial divided by the number of things that you do not need. In this case, we're picking all four of the letters. So you're going to say 4 factorial over 4 minus 4, which is 0 factorial, which is 1. So 4 factorial, which we just calculated as 24, and 0 factorial, which is 1. So 24 over 1, or simply 24 ways. What if I do not pick all four of these letters? If I want to see just the 2-letter words, how many 2-letter words I can have? So I have 4 letters to choose from, but I want to pick only 2 of them. How many different arrangements are possible? So I'll say 4 factorial divided by number of arrangements that I do not need, which is 4 minus 2 factorial, and you can write down like this: 4 times 3 times 2 factorial. This is 4 minus 2, which is 2 factorial. This 2 factorial cancels it. There are 12 such possibilities. So when you're arranging the things where some objects are not distinct or repeating, for example, in this word entrepreneur, 1, 2, 3, 4, 5, 6, 7, I can arrange them in 7 factorial ways, but I need to divide out by 2 factorial ways because a is repeating twice. So this is going to be 7 factorial over 2 factorial. And let's choose another word. Let's say geometry. 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial ways I can arrange these letters, but at the same time I can say that E is repeating twice. So I will have 8 times 7 times, or actually you can do the calculations yourself. And that many arrangements are possible. So let's say if I want to arrange 4 people around a table, how many ways I can arrange these 4 people? Now it may look like it's the same thing as 4 factorial, but the thing is the first person gets to choose. If he picks this one, this becomes the first chair. If he picks this chair, this becomes the first chair. And if he picks this chair, still the first chair. So first person, when he picks the chair, that is the first chair, that's the first position, and all the chairs are exactly same. So first person has only basically one choice. So first person gets the one choice. The other three people, they can arrange themselves in 3 factorial ways. So the total arrangements will be 3 factorial ways, not 4 factorial ways. Or 3 times 2 times 1, or 6 ways I can arrange these people. So in a circular permutations, we will always have n minus 1 factorial ways to arrange people, unless we are given a reference point. So n minus 1 factorial ways you can arrange the people in a circular permutations. We also have something called a combination formula. It's like this, NCR, or you can also write like this, which is n factorial over n minus r factorial over r factorial. Now this part is permutation formula divided by the r factorial ways. Now where do we use combinations? Combinations are used where ordering does not matter. In permutation, the order of things does matter. Who comes first, who comes second. In permutations, the order does matter. As who comes first, who comes second, and who comes third. And here is the formula. So let's do a couple of questions. Here is one question that the student asked. Parking stickers contain randomly generated numbers with 5 digits ranging from 1 through 9. No digits are repeated. What is the probability that a randomly generated number is 5, 4, 3, 2, 1? So here is our probability formula. Probability is P and number of favorable outcomes divided by the total possibilities, or total possible outcomes. The number of favorable outcomes, there is only one way to get 5, 4, 3, 2, 1 if you pick 5 digits from those 9 digits. Just one outcome is going to be like this. And how many possible outcomes? Is this a permutation question or a combination question? This is a permutation problem because the order does matter. So if I write the number 1, 2, that's different from if I write 2 and 1. So the order of numbers does matter, so we're going to use permutations here. So there are nine objects, and we had to pick 5 of them. So you're going to get 1 over 9 factorial over 9 minus 5, which is 4 factorial. And you can do the calculations yourself. 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial. And that should give you the answer if you multiply these numbers. So here is another question. The mall has a merry-go-round with 12 horses on the outside ring. If 12 people randomly choose these horses, what is the probability they are seated in an alphabetical order? So probability is number of favorable outcomes divided by the total possible outcomes. So there is one such possibility that they will all sit in the alphabetical order. And since they are all seated in a circular arrangement, so remember that in a circular arrangement, we will have n minus 1 factorial. So you can simply write 11 factorial arrangements that are total here. You can leave this as answer, or you can multiply all these numbers, and that will give you the answer. Thanks for watching. Bye-bye.